Hello and welcome to this episode of Night Sky News for February 2026 with me, astrophysicist Dr. Becky Smethurst. This is the show where we chat about what you should look out for in the night sky in the next few weeks, and then we chat about what's been happening in space news in the past few weeks. In this episode, we're chatting about the delay to the Artemis mission, plus the drastic cuts that have been proposed to UK astronomy funding, and whether JWST's little red dots mystery can be explained by direct collapsed black holes, and whether the centre of the Milky Way is a clump of dark matter rather than a black hole. There's chapter markers down here if you want to skip ahead to any of those specific news stories, plus any scientific research papers I mentioned are all going to be linked in the video description down below, free to read. So without any further ado, let's kick things off and start by looking up. All right, first up, let's talk about the planets, because as we get towards the end of February, you're going to see a lot of people and news outlets talking about what's been dubbed a planet parade or planetary alignment, where 6 planets are visible at once in the night sky. Mercury, Venus, Saturn and Jupiter with just your eye alone, and then Uranus and Neptune you can see with a telescope. Now that is true for the rest of February and into early March, although it will get harder and harder to spot Mercury as we get into March because it gets closer to the sun in its orbit from our perspective. So this is not just visible on one night, but I've still seen a lot of media outlets covering this already stating this planetary parade will be on the 28th of February specifically, which to me is honestly bizarre. I don't know where that date has come from. The only thing I can think of is that the 28th is a good balance between Venus rising earlier each night and Mercury setting earlier each night. So you've got a good chance of actually spotting both on the 28th of February. Personally, I'd try and look for the planets on Friday the 20th of February because the crescent moon will be visible just after sunset as well, making almost a straight line down to the horizon from the moon to Saturn, Mercury and Venus. Now let's just do some quickfire FAQs on this planetary parade. The parade or alignment name comes from the fact that yes, they're all in a line on the sky. That's because all the planets in the solar system orbit in roughly a flat plane, but that doesn't mean they're all lined up in space. It just means that they're all over on the same side of the sun as Earth in their orbits. It's only Mars that's still on the other side of the sun from Earth so that we can't see it. This also isn't that rare. The last time this happened was February 2025, and before that, back in 2022. So if you have a clear night around the end of February, you can enjoy this planet parade. But be aware, unless you have a very clear horizon in the west to look towards just after sunset to spot Mercury, Venus and Saturn, I'm talking no trees, no buildings, no mountains, no hills in the way, the only planet you'll be able to see with just your naked eye later in the night will be the very bright Jupiter, which we're going to have in our skies for a few months yet. However, we are losing Saturn from our skies for a few months very soon. If you do have a clear horizon and you keep an eye on it in the next few weeks, you'll see it getting lower and lower in the sky each evening, setting earlier. You might even lose it in that glow of the sunset because Saturn is a yellowish colour and it's a lot fainter than Jupiter. The best time to try and spot it is going to be on the 7th and 8th of March, when it's going to be very close to the very bright Venus in the sky in what's known as a conjunction of two objects. They'll be about a degree away from each other, so it's about 2 full moon widths away, and the closer to the equator you are, the higher they're going to be in the sky for you and the easier to spot. Up here, in the same latitudes as the UK, they're only going to be like 5 degrees or so above the horizon by the time that Saturn will actually be visible. So again, unless you've got a very clear, nice flat horizon with nothing in the way, you're just not going to be able to see this depending on how far north you are. Also at the start of March, there is a lunar eclipse or a blood moon visible for those of you around the Pacific Ocean. So west coast of the US and Canada, Hawaii, Australia, New Zealand, Japan, you are all going to have a full eclipse, whereas those in the rest of Asia and the Americas will see a partial eclipse. So a lunar eclipse is when the moon is eclipsed by Earth. So the moon passes into the center of the Earth's shadow from the sun. But because the Earth has an atmosphere, light gets bent through its atmosphere, with red light bent more, which still makes it to the center of Earth's shadow, which turns the moon red. You can think of it kind of like a sunset shadow onto the moon. A sunset moon, I think, is a nicer word for this than a blood moon. So this is going to happen on the night of Tuesday the 3rd of March for those in Australasia and Asia, and in the early morning of Tuesday the 3rd of March for those in the Americas. I'll pop a link in the description below which can show you what the eclipse will look like from your location, whether it's full or partial, and at what local time it starts and finishes. Do make sure to send me any pictures of the eclipse that you managed to capture over on social media because I would love to see them. And if you're out watching the eclipse or enjoying the planet parade this month, then a fun thing to do while you're there is to notice the slight different colours that the stars in the sky have. Like, this is especially obvious in the constellation of Orion, which will be losing from the sky as we get into spring. So it's good timing for this piece of astronomy homework that I'm about to set you. So the 3 belt stars and then Rigel and Bellatrix in Orion are all blue supergiants. So they appear more bluish to the eye. I think it's really easy to see for Rigel especially. Whereas Betelgeuse and nearby Aldebaran in Taurus are both red giant stars, so they appear more yellowish red to the eye. The colour differences is because they're different temperatures. The blue giants are the hottest, so they give off very energetic light, which is blue in colour, whereas the red giants are nearing the end of their lives, so they're cooler and they're giving off less energetic light, which is red in colour. And this idea of blue meaning hot and red meaning cold is very confusing, I know, because that's not what TAPS have been telling us all our entire lives, but think of it like how the blue flame on a gas hob is much hotter than the reddish dying embers of a fire. Now, when we start thinking about these kinds of details when we're stargazing, that's when we start to do the astrophysics and not just the astronomy. And if you're perhaps thinking about becoming an astrophysicist or any type of research scientist in the future, then the best advice I can give you is that you should learn how to code, which I admit is not an easy task, not least because you have to self-motivate yourself. But today's sponsor, boot.dev, makes learning to code just a little bit easier by using tactics learned from modern game design to push you towards your learning goals. So with boot.dev's hands-on lessons that balance theory with practice, you can gain the skills that you need to forge a successful career, whether that is as a scientist or maybe a successful back-end developer. Whatever your level, whether it's complete beginner or learning object-oriented code, or even taking a step into building AI agents, boot.dev has you covered with Boots, their AI wizard bear, trained on each lesson to help you if you get stuck. I just love that he doesn't give you the answers, he asks you questions to deepen your understanding and guide you through a problem. But there's also the lovely boot.dev Discord community, which has tons of real humans to help as well. And if you're still completely lost, the solutions are available. Trust me though, coding is not something you can learn overnight. Like learning any language, it takes time. So boot.dev's curriculum reflects that. It takes around 12 months to go properly in depth on both the theory and the practice. All of boot.dev's content is free to read and watch in guest mode, but a paid membership unlocks the interactive features like the hands-on coding, AI assistance, and the progress tracking. So if you go to boot.dev, you can try out their courses for free first, and then you can use my code Dr. Becky to get 25% off your entire first year if you choose the annual plan. Or you can click on the link in the description as well. So a big thanks to boot.dev for helping teach the world to code. And now let's come back down to earth and chat about what's been happening in space news in the past month. All right, first up, let's talk about the news dominating the headlines. NASA's Artemis mission to the moon has unsurprisingly been delayed. This is the Artemis II mission, which will make exactly the same journey as Artemis I, looping around the moon and coming back to Earth, but this time with a crew of 4 astronauts on board. As we heard last month, the SLS rocket with the Orion capsule on board was rolled out of the Vehicle Assembly Building at NASA to the launch pad, and on Tuesday the 3rd of February, NASA then did what's called a wet dress rehearsal, where they actually loaded the rocket fuel into the SLS and got a ground crew to practice closing up the Orion crew capsule as if they were taking off on the real mission. If all had gone well with that, the launch would have then been as early as that first weekend of February. But during that wet dress rehearsal, there was a rocket fuel leak of the liquid hydrogen. A quick workaround from the engineers managed to solve the issue at first, but the countdown was eventually halted with 5 minutes to go in the dress rehearsal countdown because of a spike in the rate the hydrogen was leaking. So that means not all steps for the dress rehearsal were completed, and they'll need to do another wet dress rehearsal before launch. But as we spoke about in last month's Night Sky News episode, given that Artemis I had 3 scrapped launch attempts, it's not surprising news that Artemis II has similarly been slightly delayed, with NASA announcing they're now targeting the launch window at the start of March. Next up, I just want to raise some awareness about some planned cuts to astronomy, astrophysics, and space science funding that's been proposed in the UK. So the Science and Technology Facilities Council, or STFC, have outlined that the budget for astrophysics, particle physics, nuclear physics together will drop by around 30%, but that the community should also plan for scenarios where their funding is reduced by 20, 40, and 60%. So why is this happening? Well, according to UK Research and Innovation, UKRI, it's because STFC's cost base has increased significantly due to the type of facilities and services it manages. What that essentially means is that science grant funding is directly in competition with the facilities facing rising costs from things like increased energy bills, like everybody else on Earth right now. The facilities are used by many other disciplines, though, from physics to medicine, and yet it's astro and nuclear physics that are the only areas expected to make these research budget costs to offset this. So it's a huge hit for the community. Like, research budgets go towards paying people, right? It's early career researchers like myself and PhD students. So if these funding cuts go ahead, there's essentially going to be less jobs in the future for the current up and coming generation of budding scientists, and therefore less research getting done here in the UK, which is very frustrating as a nation that has always, punched above its weight when it comes to astro and space science. Now, these are still proposed cuts. So if you are a UK resident and you oppose this, I will pop a link in the description to a template letter that you can send to your MP to ask them to oppose the proposed changes in Parliament. All right, on to some science results now, though. And I first want to talk about this work from Piccucci and collaborators, explaining the little red dots, one of JWST's mysteries of the early universe that have been spotted all over the deep galaxy images JWST has taken. So, the little red dots were discovered as part of the search for growing supermassive black holes in the distant universe, which we see as it was billions of years ago because light takes time to travel to us. Specifically, we look for emission from hydrogen that's usually given off at a very specific wavelength or energy or color of light. Because if you've got hydrogen spiraling around a supermassive black hole because it's taking that material in slowly but surely and using it to grow in mass, a growing supermassive black hole, that hydrogen is moving at huge speeds. So the emission you get from it is smeared out in like a Doppler shift. And we call these features broad lines in the spectrum of a galaxy, and they indicate there is a growing supermassive black hole here at the center. And when people search for these broad lines in JWST spectra, they found a whole bunch of them in galaxies that then look like little red dots in the images, hence the name. Now, if that is indeed what these things are, then these are very compact objects with very little mass in stars in the galaxy compared to the supermassive black hole. Typically, in the universe around us today, a supermassive black hole is about 0.1% of its galaxy's mass in stars, and the two are thought to co-evolve together, staying at roughly the same ratio throughout their lives. That would mean that these little red dots would have overmassive supermassive black holes, in which case they should be giving off a lot of X-ray light, for example. But so far, we've not detected any X-ray light from them. So maybe they're not supermassive black holes then. Maybe they're instead just really compact galaxies, just a ball of stars. But then that's not something we'd expect to form, at least in our current best model of the universe. So as you can expect, there's been a lot of work trying to figure out what is going on here, with lots of research papers suggesting different explanations, a few of which I've covered on this channel before. And so, the latest new explanation has come from Piccucci and collaborators, who have claimed that a direct collapse black hole could explain a lot of the properties of JWST's little red dots, which is really exciting. But what actually is a direct collapse black hole? The only way that we know of to form a black hole that we have observational evidence for is when a star runs out of fuel and dies, going supernova, throwing off its outer layers of gas, and the core then collapses under gravity to form a dark star, one so dense that light can't escape, aka a black hole. But that process will only form a black hole that are anywhere from about 5 to 50 times heavier than the sun. The black hole then has to grow up to 1,000,000 times the mass of the sun to become the supermassive variety we see in the centers of galaxies. And that growth takes time to actually get material close enough to a black hole so that it actually gets trapped there. And surprise, surprise, JWST has been finding supermassive black holes in the early universe that are overmassive because there's just not been enough time. The universe hasn't been around for long enough for them to grow that big. So, people have proposed the idea that there might be a shortcut, a direct collapse black hole, where you skip making stars from a big gas cloud and you skip the supernova, and instead you take that gas cloud and just collapse it straight down into a black hole around 1,000 times heavier than the sun, which then seeds the growth of supermassive black holes. They're now often used in simulations of the universe to help jumpstart black hole growth, but we've no observational evidence for this actually happening yet. Or do we? Because Beccucci and collaborators simulated what would a direct collapse black hole actually look like to us. What do we have a hope of actually detecting with JWST from the material around a direct collapse black hole? Because we can see that light from the hydrogen that's moving fast around the black hole, so fast that it glows, and then that light also hits into other gas and dust around the black hole, giving them energy so that other wavelengths of light are also released, creating certain signatures that we can look for. So this is what Beccucci and collaborators have found for the amount of light given out at each wavelength or color of light. The yellow line shows what a cloud of hydrogen gas around a direct collapse black hole would look like. But then the purpley red line shows what happens to that light if there's also dust, so heavier elements than hydrogen in that gas cloud that then blocks some of the light, changes it and re-emits it in certain ways. The blue line is then a typical spectrum from a little red dot observed by JWST. And I'm sure you'll agree the agreement between the blue line and that purpley red line is very good. What's interesting about this is that there's no starlight needed to make the two models match, only a normal sort of expected amount of dust blocking some of the hydrogen emission from the gas around the black hole. Plus, this direct collapse black hole scenario could also explain the lack of X-ray light found from little red dots, because the gas has to be really dense to produce a direct collapse black hole, dense enough so that only the highest energy X-rays would ever make it out of there. In fact, there are many properties of little red dots that Beccucci and collaborators argue through this paper that their simulated direct collapse black hole model can explain. So it will be really interesting to see how the observational research community responds to these claims. So make sure you subscribe so you don't miss when I inevitably cover that work in the future. And finally, another black hole story this month, this time a little closer to home, with the supermassive black hole at the center of our own Milky Way galaxy, with this work from Crespi and collaborators, who looked at the orbits of stars in the center of our galaxy and found that those orbits fit a model of a blob of dark matter just as well as a model of a supermassive black hole. Now, this is not a new idea. The debate of what's at the center of galaxies goes back decades. I covered a lot of this in my book, A Brief History of Black Holes, if you want to check that out. But to briefly summarize, as recently as the 90s, astrophysicists were still referring to what was at the center of galaxies as massive dark objects. We knew there was something there that we couldn't see. So the question was it one single supermassive black hole or even a swarm of smaller black holes? Although that idea lost favor because it would be completely unstable. Or is it a lump of dark matter? So not super dense and concentrated like a black hole has to be to trap matter and light, but almost like a blob of diffuse gas, just made out of dark matter that interacts gravitationally but doesn't interact with light, the electromagnetic force. So there's no emission, absorption, or reflection of light. I have a whole video on all the observational evidence that we do have for dark matter. If you want to check that out, I'll link it in the video description down below. But what it means for the center of the Milky Way is that if you have two objects of the same mass, one very dense as a black hole and one more diffuse as a cloud of dark matter, they will pull ever so slightly differently on objects nearby to them. At greater distances, the differences just wash out, but for those stars orbiting closest to the center, there should be a measurable difference, albeit one that is very, very small. Here's a plot, for example, of the positions of the closest star to the center of the Milky Way, which is known as S2. The observed positions of that star taken over its 12-year orbit of the center of the galaxy are shown in the gray dots there. The black dash line then shows what that star's orbit would be if it was orbiting a supermassive black hole, whereas the red and blue lines show what the orbit would look like for some different varieties of dark matter cloud models. I promise you there are some very very minor differences here if you zoom in, especially on the right-hand side there. Here's a similar plot, but for a few stars further out. Again, the solid colours are the dark matter models and the black dashed line is the black hole model. And all of these are compared with the circles that are plotted there showing the observed positions of each stars, which for these stars, we haven't been observing long enough to see a full orbit just yet. And so what Crespi and collaborators have claimed is that we don't have enough evidence to distinguish whether the black hole or the dark matter model fits the data best. Which is true, but that's really down to the fact that the stars orbiting at these distances to the centre, the differences expected in the shapes of their orbits from one model to the other are minimal. And add to the fact that we can only measure the stars' positions to a certain degree of accuracy, it's more that we don't have accurate enough data to do this test to any degree of accuracy. And that's a subtlety that I think got lost in a lot of the mainstream media coverage of this work. However, having said that, Crespi and collaborators also extend their dark matter model from the centre to the outskirts and modelled how the whole galaxy would expect to rotate, including stars on the outskirts, and compared it to data from the Gaia mission, which mapped the positions and velocities of 1 billion stars in the Milky Way. And Gaia observed a slight slowdown in the rotation of stars at the edge, which Crespi and collaborators say their model also explains. Which is very interesting and gives more weight to this idea that it is maybe a dark matter cloud at the centre of the Milky Way. But I can practically hear all of you screaming at your devices right now, what about the image of the Milky Way's black hole the Event Horizon Telescope took a few years ago? Well, Crespi and collaborators claim that a central cloud of dark matter can also produce shadow-like features with sizes comparable with the measurements of the EHT collaboration when applied to Milky Way-like galaxies. AKA, you can get this bright ring with a dark centre, like seen in the image that the Event Horizon Telescope took, but only in some specific cases of the dark matter models. So I do think this is a really intriguing idea, and I'm excited to see what further research with more accurate star positions might reveal in the future. But for now, personally, I don't think there's enough evidence for this to overturn all the evidence that we have in favour of the accepted black hole hypothesis just yet. Alright, that's it for Night Sky News for this month. As always, if you snap any pictures of the night sky or you see a space news story that you want me to cover in a future Night Sky News episode, then send them my way over on social media. But until next time, everybody, happy stargazing.